All right, problem 20 follows very naturally from problem 19. So here we're looking at the symmetric group on 4 elements. Take a look at the previous video for a full explanation of what the symmetric group is. But here we'll assume you've already watched that. So S4, and we're looking for elements of S4 such that x to the 4 equals E. There's our formal definition for S4, and let's hop straight into what its elements are. So remember, the elements are the maps. So we always have this identity element. So here we're calling these guys objects. Object 1 is in first position. We think of these in order. 2 is in second position, and so on. And the identity element, instead of rearranging them, it just puts them back in the same position. So clearly this, if we do this 4 times, if you don't permute anything 4 times, you just leave it alone, it will be the same as before you left it alone. So this is definitely going to be one of the elements of S4 such that x to the 4th equals E. Now, we also have a bunch of 2 cycles in S4. So this is what the 2 cycles look like. And the question is, will these 2 cycles, when we apply them 4 times, remember multiplication is defined to be composition, so we're just repeating the map. If we do these map 4 times, will we get back the identity? Well, if we look at this bottom right map here, 3, 4, so remember the element of S4 is the entire map. If we look at this, let's just say we do it twice. So when we saw this in our last problem, when we have a simple transposition, which is what this is called, if you do it twice, you essentially undo it, right? 1, 2, 3, and 4 are in a row, so we're back to the identity, which means that this element has the property that x squared equals E. Well, if x squared equals E, then what is x to the 4th? You can think about this 2 ways. One, you can just keep drawing lines and maps, or we can think that x to the 4th is x squared squared, and we know x squared is E, so this is E squared, which is then E, right? We also know that all these 2 cycles are going to behave the same way. This we can see, right? Like if we switch 1 and 4 once, they're out of order, and then every even number we use, they're back in order, because then the 1 and the 4 go back together. So that's all the 2 cycles. So all of these 2 cycles are going to have the property that x to the 4th equals E. But instead of taking 1 2 cycle, we could have, because we have 4 elements, we could take 2 2 cycles. And here's all the ways to take 2 2 cycles. So these 3 elements are elements of S4 because they permute the 4 objects into a different order. And the question is, will these also have the property that x to the 4th equals E? Well, we certainly expect them to, but how do we know that they do? Instead of just writing them out, just think in this first example here, this 2 cycle or this transposition and the one next to it, the 3 4, they're acting independently. And we know that 1 2 to the power of 4 equals E, and we know that this 3 4 element to the power of 4 equals E. So when we combine these 2, not in a composition way, but if they just sit next to each other, that the elements generated by 2 cycles will also have the property x to the 4th equals E. So indeed, all 3 of these elements also have this property. Now let's look at the 3 cycles. Do we think the 3 cycles are going to have this property? Well, certainly not. So all of these 3 cycles are going to behave the same way. And if we can look at any one of them, we'll look at 2 4 3. And just look at where object 2 goes. So object 2 starts in second position. And now where does object 2 go after one application? Object 2 goes to 4th position, and then it goes to 3rd position, and then it goes back to 2, and then where does it go? Goes to 4. So in this would be x. This would be object 2 after one movement. X squared, x to the 3rd, and x to the 4th. Right? So object 2 actually ends up in 4th position when we cube it. And that makes sense because this 3 cycle, if we apply it 3 times, should equal E. So when we apply it the 4th time, it's just like applying it once. Right? So to write this out, when we have 2 4 3, we know that x to the 3rd equals E. So then what is x to the 4th? Well, x to the 4th equals x to the 3rd x1, which then equals E x to the 1, which is not E because x in this case is this map right here, which is not E. So none of these 3 cycles work. Now what about the 4 cycles? Well, we saw in our last video, and it's easy to see here, that the 4 cycles move everything 4 times. And so if you follow each of these elements, the 1 is going to move to the 2, then the 3, then the 4, and then come back to the 1. And that's the idea. So it doesn't matter which route we take, right? This map here looks a little confusing. It doesn't matter because we know if we apply it 4 times, where's the 1 going to go? It's going to go back to where it started. Where's the 4 going to go? It's going to go back to where it started. So all of these 4 cycles definitely work. Thanks for watching this video. I hope you enjoyed it. Make sure to subscribe so you don't miss out on future videos. And if you have a question about this problem, or if you'd like to request a solution to a different problem you're working on, let me know in a comment below.